A rigid body is a system of particles with a finite size that do not get deformed under the influence of any external force. The distance between any two particles of an ideal rigid body does not change even when it is under the influence of external forces. Let us now observe a bicycle in motion. If A and B are two particles on the frame, as the bicycle moves, the displacement is the same for both A and B. It implies that the velocity of particle A is equal to the velocity of particle B. This is also true with all other particles of the rigid body. Such a motion of a rigid body in which the velocity of all the constituent particles is the same at any instant of time is known as translational motion. Let us consider another rigid body, a door. Mark 2 points P and Q on the door and observe their motions as the door is opened or closed. When the door is in motion, do the 2 points P and Q have the same displacement? Their displacements are not equal. Hence, the motion of the door is not translational. This is known as rotational motion of a rigid body. The door is fixed to a line passing through the hinges. This fixed line about which a rigid body rotates is called the axis of rotation. When a rigid body is in rotational motion, how do the different particles on it move? When a rigid body is in rotational motion, every point on it moves along a circular path with the center on the axis of rotation, and the plane of this circle perpendicular to the axis of rotation. The rotating blades of a fan, the steering wheel of a car, and the Earth's rotation are some examples of rigid bodies in pure rotational motion. In all these examples, the axis of rotation is fixed and the rigid body rotates about it. Now, watch a spinning top. How does the motion of the top differ from that of the rotating bodies shown earlier? Here, the top is rotating about an axis. This axis of rotation of the top is not fixed, but rotates about a vertical line passing through its point of contact with the ground. This rotating axis forms an inverted cone, and this type of motion is known as precession. Even the motion of a grinding stone is of this nature. The axis of the grinding stone rotates about a vertical line that is normal to the base of the lower part of the grinding stone. In these examples, even though the axis of rotation is not fixed, the point of contact of the body with the ground is fixed. Observe the motion of the rolling wheel of a bicycle. The motion of any rolling body is a combination of rotational and translational motions. If a rigid body is fixed to an axis or a point, its motion is pure rotational motion. If the rigid body is free, it can have pure translational motion, or a combination of translational and rotational motion.